In this video, we are going to take a look at another related rates problem. So let's jump right in and look at our related rates problem. A 13-foot ladder is leaning against a wall. The bottom of the ladder is being pulled away from the wall horizontally at a rate of 4 feet per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall? A lot going on here. Let's first try to draw a picture. So we have this wall, we have this ladder that's leaning up against the wall. Those rungs are not very well spread out. What do we know about the setting? Well, the distance up along the side of the wall, so this distance right here, is that fixed or is that changing? Well, that value is changing. Let's call that value, let's call that A. What about that length? Is that length fixed or changing? That length is also changing. Let's call that value B. And the length of the ladder, is that fixed or changing? That value is fixed, so that length is 13. All right, what equation could you come up with that relates this value of A and this value of B? Well, we have a right triangle, and so we could use the good old Pythagorean theorem. A squared plus B squared is equal to C squared. A squared plus B squared is equal to 169. And now what are we going to do with this? Now we are going to take our derivative. We're going to take it implicitly with respect to t. So derivative of a squared is 2a dA dt. Derivative of b squared is 2b dB dt. And we take the derivative of the right-hand side. When that's a constant, it's really easy to overlook it and just rewrite that constant. The derivative of a constant is 0. All right. So now we've done that. Now we need to plug in what we know. So what do we know? That's a good question. So we want to know how fast is the ladder sliding down the wall when the bottom of the ladder is 5 feet from the wall. So we're going to look at when B is equal to 5. Could you tell me the value of A when B is equal to 5? Well, it's still part of this right triangle, so our Pythagorean theorem should hold. And so when B is equal to 5, A squared plus 5 squared is 13 squared. And so A is equal to 12. So we can plug in a value of 12 for A. We're going to plug in a value of 5 for B. We know it's being pulled away horizontally at a rate of 4 feet per second. So is that a change in A or is that a change in B? That is a change in B. So that's going to be 4 feet per second. We're going to figure out how fast, what is dA dt. Now, that is 4 feet per second. Should that be a positive 4 or a negative 4? Is this value of B, is that getting larger or is it getting smaller? Since it's being pulled away from the wall, this value of B is getting larger. And the value of A should be getting smaller. So I should end up with a dA dt that's a negative value. Let's go ahead and solve this. We have 24 dA dt is equal to negative 40. So that piece right there is 40. Subtract it to the other side. Divide by 24, and we have dA dt is negative 40 over 24, which is negative 10/6, or negative 5/3. Feet, feet per second. So it's sliding down the wall at 5/3 feet per second. When I said the word down, that was the negative. So it's changing at negative 5/3 feet per second. Great. That is what I would consider one of the more standard kinds of examples in related rates. With that, again, don't get lost too caught up in details of any one example, right? So let's think about the big ideas that are happening. So we drew a picture. We found an equation that related the variables. We took our derivative implicitly, and then we plugged in the known values. And we might have to find some of those values using that known information. We might have to solve for other values, so we solve for A. But that's our process. This is not just because we happen to have a triangle. This equation is because it was a right triangle. But you want to try to come up with what equation relates to the variables. All right. We'll have one more video where we look at one final example here. I will see you next time.